gas find it, stuff like that. So that's kind of fun. Not that it matters to you guys too much, but if that thing starts ringing, that's me looking for the clipboard with all your grades on it. Nick mentioned to me, to mention to you, don't, I think he used the word pollute, but pollute your workstations where you're working with Ryan with your carburetors. So if you have your engine all tore apart and then you start taking your carburetor apart on that same bench and then there's little pieces and parts and you're like, so he says, which I think I would back up, when you're working on your carburetor, do it in your little workstation, like the sheet metal area, and then we'll have our project separated. The other reason that that will be helpful to you today is I closed the dividing door and I turned the air conditioning on. It wasn't on and it's like almost 80 degrees out here. So your workstation area, oh shoot, is there a couple people in back? Find a friend otherwise. Your workstation area is up front. Will be air conditioned today. Anything out back, not so much back there. Carbs got to go in and out, stuff like that. So if you're working on carbs, stay on this half of the lab and it will be a little bit more comfortable. So I figured half of an air conditioned lab is better than no air conditioned lab. So I just did it. So that's what we got for that. I believe I heard congratulations is in order for Lee. Did you guys give him a round of applause yet? Certified mechanic. So, is anybody gone today? Is everybody else? Everybody's here. Okay. Everybody is back. Good to know. All right. So we are continuing with fuel metering class. We'll be going a little bit deeper into carburetors, and then tomorrow's deeper yet. So we won't, have everything. There were a couple questions that I'm going to cover in the first couple slides on the lab that I didn't like, I rewrote. So we're going to redo a couple of those questions. I regraded some. So if you have an issue with the grade, come see me as always. I'm happy to talk through stuff with you. Most of the time in this class is similar. If I give you anything lower than like a 90 or 95 when I'm grading something, I usually try to write on it why, like especially if there's a essay answer. That's not trying to beat you up, it's trying to get it so you understand, hey, why wasn't this 100%? So if you want to talk to me about those comments, more than happy to chat through them, that's what I'm here for. And when I put come see me if you, the if you is, hey, if you want to know more, come see me. If I actually have to see you on something, I'll usually put a note in your box or I'll come get you, or you'll have a failing grade and that'll kind of force you to. So, but if you have questions, let me know. I am here for you guys. So, yeah, we'll keep rolling with that. A little commercial for you, just a kind of interesting one. Anybody know who that is? Tom Brady.
And action.
EV or Shelby?
Ooh, cut. All right, look, bring it in. So you've been working at the same job for like 22 years, right? You're just not feeling it anymore, so you retired, and that's when it hit you. Maybe all you needed was a vacation.
Let's go.
I'm not leaving. I'm not leaving. I'm not leaving. I'm not leaving.
I told you! I told you he's coming! Let's go!
And action.
EV or Shelby?
Ooh, cut. All right, look, bring it in. So you've been working at the same job for like
Remember, he was like, I'm retiring. No, I'm not retiring. Yeah, I'm retiring. Are they forcing me out? But anyway, did you hear he got hit by a car? And they asked him how he was doing. He said, yeah, it hurts. Sorry. I got a new calendar from my kids with dad jokes. So if any of the PowerPoints don't have a dad joke, it hurts. If you're not familiar, Hertz rental cars is what the commercial for. So okay, moving on. We'll be jumping around a bit from page 1 to 30, and so not quite in order today. Kind of like my jokes. Okay, this was one of your lab questions I didn't like. Tried to talk through it with Elijah. Some of these I inherited, still my fault, buck stops with me, I should have cleaned them up a little bit. This is the correct answer if you open the lab and that's still an option, just pick that one. I'm gonna explain to you why in the next couple slides. And it's pretty hard to explain that, it doesn't make sense, and it depends on where you're coming from in it. So I went through, if you picked, I think that one I just marked everybody's right. There's another one that we had, it was 11 and 13, that we'll go over as well. But sorry, trying to get all the outliers cleaned up. I'm not sure how that got changed. I'm gonna blame it on somebody else, even though it was probably me. So, review from yesterday, and I found a new slide. This is a chart, and realistically, you would say it is the places you could run a fuel-injected engine, or you could just say this is how you could set the engine up to run, but we're not saying you should. So that might be a way to phrase it, right? But because they say best economy, that should not be where you're operating a carbureted engine. Peak EGT is that line there. So this is our 15 to 1 or 14.7 to 1 ratio, if you will. So if you are on the lean side of peak, you are not where you should be running a carbureted engine anyway. So part of that question is, they didn't tell you what kind of engine, do you have gammy injectors, do you not? And the question just got complicated. So never run a carbureted engine lean of peak. That's just the answer. Fuel injected engines, when we get to them, even fuel injected, we typically don't run lean of peak. So the problem is best economy is on the lean side of peak. So if you try to use that word or phrase, best economy, anything other than gammy injectors or where you can run lean of peak, we start confusing ourselves, because the window we can operate a carbureted engine is all over here. If we switch to this slide, they switched which side is lean and rich. So I got rich here, I got lean here. So it's basically the same chart. What they gave us was also our power that we can make per pound of fuel, if you will. So that is basically saying efficiency. So this bottom line is our efficiency line. So it's this one inverted. This one says how much fuel do I have to use for each power, and the least amount of fuel for my power is when I'm lean of peak. This one is saying the most efficiency I get, least amount of fuel, is way out there, lean of peak. They also give us our horsepower chart. So if I was to put a line across here, well, that doesn't work very well. Put a line across here and say, where does it hit highest horsepower? Looks like right there. You can see highest horsepower is well rich of peak. So that's what we call our best power. So depending on how they label them and draw them, you get kind of a similar chart. So in a carbureted engine, if here's peak, we're never gonna run on that side. We're always gonna be running over here somewhere. So there's a weird question of, well, where do you get the best economy on that side of this line? Well, this is our economy line, so it's climbing, climbing, climbing towards peak still, but the engine manufacturer isn't gonna want you to run basically between those two dotted lines. If you see the dotted lines, one's 50 degrees rich of peak, one's 50 degrees lean of peak. So the engine manufacturer, and that 50 degrees can shift a little, but they basically say, don't run in here. Not allowed to use that. Now carbureted, we say, well, don't run over here either. So hopefully that helps clear it up. It was a bad question. As we get deeper and deeper in this class, these charts will keep coming back up, so you can refresh them, review them. But that's hopefully a clarification for you, and I apologize. I shouldn't have slipped that question in on you the way it was phrased. All right. questions on that, and happy to talk about it in lab with you as well. Yeah.
Why don't you want to run just bridge or just?
Like inside this box,
Yeah.
Cylinder head temperature is the highest here. So we don't want to be too hot with our cylinder head right here. The other side, notice my horsepower starts dropping significantly. And it starts dropping significantly because when we're on the lean side, it's sharp. So this is assuming, let's say 4 or 6 cylinders, and we're hoping they're balanced really well. If they're not perfectly balanced, imagine having one curve there, and one curve here, and one curve here, and one curve over here, one curve over there. So I got a bunch of different cylinders. Now, the black line might be the average of what I'm running, but if I say, hey, I want to be over on the lean side, I might have one cylinder that's basically not producing power while the other one's at peak power. So that imbalance of pressures per piston, per cylinder, is going to give you vibrations. It's going to be really hard on the engine. So that's the reason we don't want to be on the lean side. And then the other complicating factors are, remember on the lean side, the fuel burns a little slower. So we could also end up where if it's too lean, we have backfiring on cylinders. So multiple reasons, but I think I hit most of them for you. Because yeah, this is assuming whether you want to call it one cylinder or the engine on average. If we're not perfectly balanced, basically you can draw 6 different curves for each cylinder where we're at. Great question. Anybody else? Okay. That's just giving you a highlighted part that says never run your carbureted engine lean. No, no, no. Somebody's gonna find an engine somewhere that's like, well, I've never heard of. Maybe on really big ones with an auto lean function, but we're not. You're gonna need to get training on a World War II one. Gammies are fuel injected.
Okay.
Yep. Yeah, Gammies are a brand of fuel injector. This is a question, I think on lab 2 that's gonna come up, and instead of change the question, I figured I'd just give you a freebie. What configuration can your carburetor be? Front runner, they just made the word up. That's not, so don't pick that one. That's just a made up word. Side draft is, it still sounds like it's made up, but that one is true. We're gonna see that in the next slide. Updraft is the most common, that's what you guys are working on. Downdraft is not common, but you see them every once in a while. Let's picture you're in a twin engine airplane, or 4-engine airplane. If you don't have to sit behind the engine and look over it, well then a downdraft's not the end of the world, right? Around here, where you work on a lot of single engines, and if we put a carburetor on top of the engine, it's getting pretty high to look over it. And hideaway is a made up word as well. So you're gonna wanna pick downdraft, updraft, side draft to get the correct answers on that one. Let's take a couple views at a couple of those. Here is a side draft carburetor. Air's coming in one side, out the other. Not 100% sure, so give me just a second, but is the air going in or out of the side we're looking at? Out. So you guys are saying it's coming this way? Yeah, that'd be right. So, very good. Because we always want the throttle plate after the venturi. Throttle plate after the venturi, or you could say after the fuel nozzle, for lack of a better word. If it was before the fuel nozzle and we closed the throttle plate, we got a big vacuum on the backside, and our big vacuum would just suck the fuel out of the thing. So on any carbureted engine, the air is gonna go through the venturi, across the nozzle, and then across the throttle plate. The exception is a pressure carburetor, but that's not a carburetor, it's a pressure carburetor, one word, one item.
I'm having a hard time imagining what kind of packaging would make that the best option. Like there ain't specific aircraft.
think it's a Cessna 140. We'll get I think we have a picture of one later, but it's rarer, but they're out there. Sorry, I have some words. This is similar to what you're gonna see on a lot of your small engines, motorcycles, stuff like that. A lot of those are side draft or side flow, right? The difference is on your motorcycle, a lot of times you've got your venturi and your bowl sits down below with a nozzle and a jet, and it's way down there. They operate on a couple different principles where they tweak some stuff. They've actually got to suck or draw the fuel much further. Pretty much anything aviation related, you notice the bowl sits alongside the carburetor. And we covered that a little bit yesterday. We'll have some more pictures today. The idea is in aviation, most of our lines of fuel level lines are gonna be just barely below the nozzle outlet. Would you say that the line of that fuel is just barely below the nozzle outlet? No. So my understanding is in order to deal with our elevation changes, and because we're changing mixtures a lot, that's the big reason why we want the bowl close to the side of it. If you've ever had a carbureted snowmobile or motorcycle, if you go right up into a mountain, it won't work very good. If you move out to Colorado, they'll rejet your carburetor, right? They'll change the size of everything in order to work at altitude because they don't have mixture adjustments that they can do, and because the bowl's so low. So in aviation, we put them on the side, and it lets us adjust mixture through elevation better. Here is an updraft again. Haven't seen this image yet in my slides, I don't think. There's a couple nice pieces to go over. Where does the air filter go on this? Before the air inlet. So yeah, down here somewhere. So we'd have an air filter down here somewhere. That sounds like a silly question, right? But one of your exam questions tells a little story. And it's like, imagine you're a piece of air, a molecule of air. What journey are you gonna take? Have you guys ever seen that old TV show, The Magic School Bus, and they like shrink and they take? So one of your exam questions is kind of like that. You gotta imagine you're the air molecule and you're like, whoa. And the idea would be, I'm gonna go through the air filter first, and then I'm gonna go through the venturi, I'm gonna meet some fuel, I'm gonna pass the throttle plate, go into the, so just hitting on some of those points so you're taught everything on the exam. That's basically. All right, fuel inlet. If you see it over here, pretty much always, I'm gonna say always, we're gonna have a screen on the inlet. Most of our drawings in this class don't have that screen. We've got some pretty tiny orifices that we're going through, the first of which being the needle valve, right? So we don't want any crud, any pieces of sand, any dirt in our carburetor. We want it super clean. So you're always gonna have some sort of inlet screen on your carburetor. A couple slides later we'll talk about if the manufacturer did a nice job. You'll be able to take that screen, imagine the marker's the screen, you'll be able to take that screen and just screw it out and clean the screen without disconnecting the fuel line. That's nice. Some manufacturers weren't they didn't think it had that much. And in order to clean that screen, you gotta disconnect the fuel line, pull the screen out, oh, that's a hassle. So they will all have a screen there. We're gonna cover screens, I think tomorrow, we'll touch on some today. There are other screens in the carburetor as well, but that's the fuel inlet screen. Make sure you're aware that you're always gonna have one of those. All right, so we got our throttle plate, our fuel's gonna fill the bowl, and it's gonna come down through, up through our main metering jet, right? That's the restrictive point. And if the engine's running out through our main discharge nozzle. So, for review, hopefully Lee doesn't get called on. You'll be good, Lee. We'll just pass what are the metering forces in a float carburetor? That's an Anthony question. What causes the fuel to come out the jet? Two metering forces. Uh-oh. We're gonna put you back in then, we're not gonna let you sneak away with it, no. We'll get you on another one. Okay, that's gonna be Isaac Finney.
Velocity and pressure,
Velocity and pressure.
low pressure,
Say what?
low pressure.
Low pressure? Low pressure where? Yeah, so good thing we're reviewing a little bit. So the two forces or pressures we're gonna have a pressure inside the venturi right here, and we're gonna have a pressure acting on the fuel in our bowl. So as you compare those two pressures against each other, that's what's gonna cause the fuel to flow, and also you could say measure or meter the amount of fuel that's coming out. So that's what's controlling our mixture. And yeah, as a review, you got the right word in there, Isaac. The velocity of the air going through, you could say volume velocity, is what is going to cause the pressure drop in our venturi. So the pressure drop here, low pressure, compared to the pressure in here. But we want to hammer in, it's the pressure difference between those two, because today we're going to get a bit deeper on economizers, and we're going to look really close at those pressures.
Wait, so the answer is where velocity is?
Pressure, the two forces or two pressures would be the pressure in the venturi and the pressure acting on the fuel in the bowl. This pressure drop is caused by the velocity. So,
And the way it meters it is just the throttle valve, right? Like, the more you open it up, the lower pressure, which would.
the more you open it, the more flow of air I have. And then that flow of air, higher flow means higher speed through a venturi means lower pressure.
So that's where the metering comes into play, is the valve, right?
The metering is more flow through a venturi, gives me a higher pressure drop in the venturi. It's the actual pressure drop in the venturi. There is no fuel valve metering anything.
But the throttle valve, if it's closed, you will have less velocity and then
Correct.
higher pressure,
Yeah, I just want to
less
make,
low pressure.
I want to make sure you don't think that this throttle plate actually meters the fuel. So let's say my engine is turned off, even if I have the electric boost pump on, I can open my throttle all the way up. I will have no fuel flow if the engine's not running, because there's no airflow going through there, right? It's the actual airflow going through there that does the metering.
Right, but the throttle.
The throttle controls
Causes
the
yes,
airflow,
yeah.
but, yeah.
I would
That'd be
prefer-
kinda like saying when we get into fuel control units, if you said, the pilot controls the fuel flow because he's moving stuff in the cabin. I'm like, whoa, down the chain 3 steps, yes. But the actual metering is done because of the venturi based on those two pressures. Yeah.
And then the pressure in the float chamber, are you actually wanting that pressurized, or you just want it to not become a vacuum that would stop?
That's what we're gonna cover today. Typically, or the baseline thought on that, is the pressure in the float chamber will be the same as what our air inlet is, and it's gonna sense, or maybe a better way is transfer that from behind the venturi into the float chamber. So there'll be a hole from behind the venturi, which behind the venturi is typically the same as, like, I draw a line there. You'll notice it's kind of the same thing. So behind the venturi is basically the same thing as our impact air pressure.
So it's not the idling system, not.
That's what we're gonna cover today. We're gonna start playing funny games. Yep. Okay. We talked a little bit yesterday about our venturis, about a 1-piece or a 2-piece. If I was holding this one up, do you guys see what color it is? Got brass, and what color is this? Or material? silly case. That's a two-piece. I got brass, I got aluminum, it can't really, you can't weld. It doesn't, so that's gonna be a two-piece, right? If you found one that was aluminum and aluminum, now we're getting a little trickier, because is it actually forged, cast I guess would be the word, is it actually cast together, is it a one-piece? This particular one is broken, so this used to be a one-piece, and now it's a two-piece. So this one's supposed to be a one-piece Venturi. I think I grabbed the right parts. Here's another example of one that was at one point a one-piece, and then somebody broke it trying to take it out of the carburetor, which is why we are gentle or use the right tools. And then they use JB Weld to try to turn it back into a one-piece. Smatitized. So as those come around, but just a review on that, the Venturis typically come out usually one-piece or two-piece. We like the one-piece. We don't like that second piece going and getting stuck in our engine somewhere. They shouldn't, but you know, it's a thing. Okay, so up to where you guys were at. We've got this valve has a mixture control valve right here. So this is going to be what we call a back suction mixture control. So back suction mixture control. So what this one does is it says, hey, I can either have my mixture set so that the valve is open. I don't necessarily like the drawing. This would be like saying atmospheric, which they're kind of saying is the same as that impact air, right? Most of the time on these mixture controls, it's not actually open to the atmosphere. It's going to be routed through the housing, and it's going to be either impact air here, or it might come all the way back behind the Venturi. But that's kind of hard and complicated to draw, right? So they just simplify it and they say, okay, our mixture can either be set so that the pressure that it's allowing to be there on the bowl is either going to be just our ambient or our impact air, or we can turn our mixture control valve so that our mixture control valve will turn it. Now my mixture control valve will connect a hole, and usually it's up about that high in the back of a carb. You guys have a lot of these on the Marvel Shubler. I have a hard time saying that word. It's like my Biblish, if you're familiar with the story. Marvel Shublers. Oh, it's on the top side. But there'll be a hole, usually just below kind of the hinge point on there. And the idea is when I am in full throttle position, so wide open throttle, the pressure on this side here is going to be very, very close to the pressure here, right? So our pressure is going to come through, it's going to drop in the Venturi, but it's going to go back up. That's the idea. So in full throttle position, we have the mixture's basically the same here. So in full throttle, we usually want to be rich, right? So imagine full throttle, we're on the rich side a long ways. Because we want best power, we might even want a little bit more than best power to cool our engine off at full throttle. So we're quite rich at full throttle. Now, as I start closing my throttle and I get down to a partially closed position, and that's probably where it is in cruise. If you've flown an airplane, you'll know that you get in cruise and you pull the throttle, it's a significant amount back to get 65% power. So we pull the throttle back to about here, so you can kind of imagine up in this side of the throttle plate, it's a lower pressure because there's a restriction there. The engine's trying to suck air into the pistons, well, not into the cylinders. So we got a lower pressure beyond that throttle plate. So that lower pressure, if we're set towards the lean side of things, will be allowed to, now the reality is, it's low pressure doesn't move places, right? So the reality is, the vent that goes in from behind the Venturi, we're gonna have a small amount of airflow, so we're actually allowing our air to escape into the vacuum. So potato, but the pressure on the top of our fuel is gonna be lower because we connect it to above that throttle plate. Lower pressure here, remember we said 2 metering forces for metering our fuel. One's what's in the venturi, one's what's above the fuel. So if we have a lower pressure above the fuel, we're gonna get less fuel coming out of the nozzle. So that's gonna lean our mixture out when we're in cruise configuration. So that is a form of economizer that we have, or sorry, that's a, ooh, I almost said that wrong. That's a form of mixture control. There's 2 things we cover. That's a form of mixture control that we do, which is back suction mixture control. I hope I wasn't jumping back and forth too much. Our economizer can be a couple different styles that we're going to cover later in the day. I think I might jump back and forth between some. So mixture control, that's how we can, from the cockpit, adjust our mixture control. Dang, I messed up a little bit. In full throttle though, it gets a little bit harder to go very, very lean. So we are depending a little bit on the restriction coming through there. So let's get a different slide up and it'll show up. Colored picture, same idea going on is if I try to go, this one shows idle cutoff. You guys can't see it from where you're at, but idle cutoff, it's connecting this way. And the idea is my low pressure behind that plate is going to lower the pressure above the fuel, and that means I'm not pushing the fuel out through the venturi. So that's a back suction mixture control. Easy to get confused with a back suction economizer, which we'll deal with a little bit later.
So, for your mixture control, is it controlled by your throttle plate, or do you also have your,
You got another control in the cockpit.
so it's both?
They will interact with each other, but it's the red control in the cockpit for do I want to be lean or rich.
Right.
That red control in the cockpit is going to adjust this valve right here.
And then the throttle plate,
That's usually the black knob in the
right,
cockpit.
but like if that changes, it can control the mixture just a little bit also?
It's going to affect it, yes. I would not use the word control so much as affect. Yeah. All right. So, back to this one. If our throttle is wide open on this aircraft, wide open, it's going to be a little trickier to turn the mixture all the way off because my mixture control, I'm not doing a whole lot, right? If I switch this over to be connected to there, when the throttle's wide open, I don't have much negative pressure on here. But who in their right mind, when the throttle's wide open, wants to shut the fuel off? It doesn't really make sense, at least all the way off. So they're a little bit of a different animal. You won't see them too much. Usually when you want to adjust your mixture is when you're at either a cruise or idle power setting. If you're at idle and this thing's all the way over like that, now I got a ton of suction and I can very easily lessen the pressure here and basically have no fuel coming out. So that's a back suction mixture control. Here, yes.
So is the point to stop all fuel?
It's
at
so
the-
as I climb in altitude, I can adjust my mixture.
But
so-
you would never want to shut fuel off completely out of the nozzle, right?
Not, when you shut an airplane down, you do. On that style, it's pretty hard to do that. You're probably gonna have a fuel valve you shut off if you wanted to.
But the purpose was to, you said you have lower pressure at the float, right? Is that lower in relation to normal or lower in relation to the?
Lower in
the stroke
relation
pump?
to what's going through the venturi.
So then you wouldn't have still have some fuel coming out if the.
No, because if this is closed, it's gonna be super low over here because the engine's trying to suck. So this pressure will be actually way lower pressure than what's here in the Venturi, because my engine's gonna be hooked up to that one trying to suck that baby out.
So with the idling, like how are you getting fuel then? Or are you not? Is that the point?
Idle, yeah, it's gonna have to go through the idle.
Okay.
Yep, exactly. So, a lot of carburetors have a mixture control that you guys are working on, and that one's stuck, there we go. That has that physical mechanical on the inside of it, right? And some of our images show it as, I guess that was the last slide. They'll show it as a plunger coming down, or a point coming down. So this mixture control, you'd say, is more of a physical mixture control, where what we're covering today is, hey, there's a thing called a back suction mixture control. Less common, but they're out there. All right, so back to this slide. This carburetor is one of these back suction mixture controls. So here's the mixture control we pointed out yesterday. I've got lean, I've got rich. So what happens is I've got, it's hard to see, but there's a hole that goes from here to up above the Venturi. So that would be this hole here, basically. So there's a hole that goes from here to above the Venturi. There's another hole that's right in here that just goes to above the float. So that's above the float, and that would be the one that goes from, is it here? Let me get my slide on right. To the float bowl. Oh, I'm sorry, just to the float bowl. So float bowl to that valve. So if the big hole here that goes back behind the Venturi is plugged off, and this little plate will rotate, right? So I can either put a tiny hole above here, a bigger hole, a huge hole. If I have that plate so that one is totally blocked off, so I say those holes are plugging that off, the pressure acting on the fuel in our bowl will be what's above the Venturi, which is going to be that negative pressure above the Venturi is basically where they're at. So if I've got a negative or a low pressure above the Venturi and I put that in the float bowl, I'm not going to have any pressure to force fuel through my main jet, my main nozzle, and basically that's as lean as I can get. Now if I spin this adjuster all the way to rich, basically what I'm doing is I'm going from lean over here to rich over here, and I'm putting this big honking hole that is from behind the Venturi, and I'm going to connect behind the Venturi up to my float bowl. Now yes, we're also connected above it here, but this passageway is much smaller than the big passageway. So basically, through this, if I take this one would be behind in the other drawing, and like I said, they don't draw it all the way through. That'd be the one where if you drew it all the way back and said, okay, there we go. So it basically allows us to say, hey, I can adjust my mixture, leaner or richer, by sensing behind the Venturi or sensing up past the Venturi closer to the throttle plate, above the throttle plate on a lot of them. So when you're working on your carbs, you will be asked, hey, what's the mixture control in here? How does it work? Where are the passageways? If you have this carb, you got to understand what's going on. If you have one of these carbs, you got to understand what's going on with the mixture control. So just a couple different styles, a couple different ways to look at it. We are going to shift gears away from mixture and go into our economizer now. So our mixture control is something the pilot controls, right? We've got a red knob. I can go rich, I can go lean, I can adjust it with multiple ways. It can be a valve, it can be a back suction mixture control. The economizer is not pilot adjusted. The economizer is just something that's going to be engineered or built into the carburetor, and it'll automatically do its thing. And basically, the economizer, that word is a little deceiving, because it's reverse acting for what you would normally think. When do I need to be the richest? Not counting idle. Take off, full power. I want to be the richest at full power. So full power here, I want to be the richest. I want to be way back here to cool my engine at full power. So that's where I want to be the richest. So when you use the word economizer, what you're saying is normally we run full power. Wow. But when I'm in cruise, I want to be a little bit more efficient than that. So I want to lean it out when I'm in cruise. So that's where that word economizer comes from, is I go from a super, super rich setting when I'm at full power to I want to automatically be a little bit leaner when I'm in cruise. A little bit leaner means I have better economy, which means economizer. So that's where the word comes from. Does that part at least make sense? Okay. The reason I explain that and the problem with it is the same concept, the same component, the same device might be called an enrichment valve. An enrichment valve is going to be a device or a valve that will go from in cruise, which is where we normally operate, and it says, well, I need to be richer when I'm at full power. So when you go to full power, I'm going to enrich in your mixture. So whether you want to call it an economizer or an enrichment valve, you're talking the same exact thing. It's just, when are we starting the conversation? Does that make sense? Yeah? So, an enrichment valve is going to be, and we'll have them in a couple slides, but one that maybe the enrichment valve opens another orifice for fuel, so that at full power I have the main metering jet and another metering jet, so I get more fuel. So that would be the better term when you're using enrichment valve, because it's going to make it richer at full power. Economizer, it's just they used a bad term there. There are several ways to do an economizer. We're going to cover each real briefly, and then we'll take a break and we'll go deeper into each one. The three you guys have to remember are the back suction economizer. Back suction economizer is the one that I got a little bit off with our back suction mixture, because they're very, very similar, right? So a back suction economizer is basically going to say, if I'm not at full power setting, we're going to have a little hole in the carburetor just above that plate, so that if the throttle's partway closed, we're going to drop the pressure above the fuel just a little bit and lean you out. So I'm going to lean you from a really rich setting to just a little bit leaner when you're in cruise. Does it automatically. It's not a valve the pilot's doing, it's just drilled in, built in. So that's what a back suction economizer does. We'll talk about those in a little bit more later. Additional orifice economizer is going to be more like what's in the drawings down here, where when I go to a full power setting, I'm going to have two orifices that fuel can get from my bowl up into my discharge nozzle. We've got our normal metering jet, and then there will be an economizer metering jet. So when I go full throttle, I got more passageways for the fuel. Sometimes that lever or valve is actually controlled based off manifold pressure, and we're going to deal with that in a minute. That starts to really kind of confuse back suction and whatnot, but we gotta explain the difference. But those are, I call them additional orifice. This one says a pressure operated economizer system. The last one is there's actually, FAA doesn't give it a name. I don't know if you come up with a name, we'll maybe put your name in the book. I call it the plug main nozzle air bleed. That doesn't sound right. Plug main air bleed nozzle economizer. See, we gotta come up with a different name for that thing. So that's this one. Remember, if we plug off the main air bleed, we are gonna run richer. So this carburetor will, at full throttle, it'll plug off the main air bleed, making it run richer. So is that an economizer or is it an enrichment valve? It's a valve. right? Yeah. So it all depends on if you start at cruise. If you're at cruise, I go to full power, the valve closes, giving me a richer mixture. But if I started at full power and I come back to cruise, now the valve opens and gives me a leaner mixture. So now I'm back to an economizer. So that's why. Either word is usable, and you gotta be careful who's talking and what one they use. Let me blank this out, so I gotta double check. Couple slides ahead. Yep, that's where our break is. Take a break, come back at, let's say 35, so that's an 8-minute break. Yeah,
Can I get you to go over all the pressures and stuff on an actual car like this sometime?
all the pressures,
Yeah, like,
all the changing pressures.
yeah, 'cause
Yeah, that's what we'll
I'm
do.
getting pretty confused.
That's what we'll do when you explain one to me.
Okay.
But I mean, we could do it. We could do it on this one right here.
It seems like so many different things happen differently depending on how the throttle is
And depending on what style car you have. Because, so, to go over all of them, yes, that's what I'm gonna do with you for the next 3 days. Cause that is what we're doing, there's a lot of different systems. So part of it is, if you wanted to say that, let's pick a carb and say, what are the pressures in this one? And that's why we have you say, take them apart and we'll look at it. And then I'd say, hey, let's do another one, do the same kind of thing. But this carb is a back suction mixture control. So we know the metering pressure for the fuel is gonna be pressure difference between here and here. If we have airflow through, this pressure will drop compared to this one, right? Now, when we tinker with it, with our mixture valve in the cockpit, if I go to lean mixture on this one, I'll connect my float chamber up back here, which is going to be a lower pressure. So let's just put some numbers in that are imaginary. Let's say the pressure here is 10 and the pressure here is 6. I got a 4-unit difference. I got fuel coming out. If I connect this to here, let's say halfway, because it might only be halfway, and this one is 3 up here. Now I'm going to allow some of that 10 to bleed into the 3, which will lower it to 8. Now I only have a 2-unit difference, so I'm going to have less fuel coming out. So that's.
now what happens when all that's like that and then you open the throttle?
So I open the throttle all the way up.
Now you're not gonna have
Now,
difference.
if we start again with our numbers, I probably still have 10 here, sensing here, right? Instead of 6, maybe I only have 3 here, because higher volume of air. So now I've got much lower, so I'm gonna have a 7-unit difference. I got a ton of fuel coming out. If I try to go lean at this point, I can still do it because there is a little restriction with, the Venturi and all that stuff. But the pressure up here is probably, let's say 9. So as I connect to that 9, I get this down to 9. I am gonna be able to lean, but not much, right? And part of the idea is we start to lose some of our leaning ability with this style. But that gets back to why would we ever wanna lean at full throttle?
So if your mixture control is set to where it's taking a pressure measurement or basically bleeding pressure from behind your throttle,
Yep,
right? When your throttle's wide open, you're gonna have a high pressure through your throttle, right? So that's gonna
Yeah.
put higher pressure on the float chamber.
yeah, it's not gonna be higher here than here. It'll still be slightly lower,
Okay.
just because we do
How
have,
is it
we
doing
do have
anything?
some restriction. So you'll still have somewhat of adjustment there. But yeah, at a full throttle setting, you don't have as much as if you had, be later on. You won't have as much as if you had, come on. I'm looking for one that, let's see if we get to one.
Oh,
Economizer. Yeah, okay, so this one would be showing, this is your mixture. Just ignore this for now, we'll come back to that. If that's plugging the hole, that would be idle cutout or full lean. If I unplug the hole, it would be full rich. So So our fuel normally is coming down here. So on that one, when I adjust the red thing in the cockpit, I'm just opening or closing this orifice.
Right,
And I'm not playing any funny games with the pressure up here.
okay.
The pressure up here is always gonna be just fed from either the back of that Venturi or, so these ones are simpler to understand.
Yeah.
And we don't have all this funniness going on. The issue is a little bit less automatic control. We don't get that nice, rich, lean, rich curve, as much as we do with the ones that are playing with pressure games. Because the carb manufacturers figured out, hey, we can play some really funky games with these and let the pilot not have to do as much work,
Gotcha.
so. detail some of these. We basically covered the back suction economizer already. It's hard to see on this. I put it up here. I was going to try to explain it a little bit more, but it's just really hard to see the back suction economizer. This one doesn't have a hole that they're showing you back here. When this is closed part way, so in your cruise configuration, it's closed part way, there would be a little bit of a negative pressure on our, usually it's like a stack of holes for our idle, right? Those stack of holes typically come down to the jets. So that's normally not going to be considered back suction economizer, but they can do that sometimes. Usually if it's back suction economizer, there's a additional hole on the side of them. And I have a slide coming up that'll show you that. So we've pretty much covered back suction economizer, the idea being throttle's partially closed, I got a little bit lower pressure above my throttle plate, and we're gonna, it's not allow that pressure on top of the bowl, but we're basically venting the bowl pressure out into there, right, is the technical way. So additional orifice economizer. Here's our main metering jet, here's our economizer. So when I go to full power, so when I rotate it up, this is gonna come up, that's gonna unplug our economizer jet port, and now I can have fuel going through our economizer jet, so I get more fuel when my throttle is in the full throttle position. That one's super simple on this slide, right? Everybody gets that?
So I'm showing the economizer to the throttle plate.
So this is theoretically showing in cruise, so it's slightly lean, because the hole is plugged. Is that plugged? It's plugged. The dotted line, now I would be open, so that little point is gonna be up there, and that would allow the fuel in. So full throttle, we open up a port to an additional metering jet, our economizer metering jet.
Doesn't it lean it though in cruise?
Full throttle's not cruise, yes. So if you wanna go to the other side of that train tracks and start in full throttle, so if we started in the full throttle position with this up, and now I have fuel coming through there, and I go to cruise, so I turn this down to cruise, and I plug that hole off, plugging it leans it,
Okay.
which would mean an economizer. So yeah, that's back to, is it an economizer, or is it a fuel enrichment valve? Whatever the manufacturer decided to call it.
And is the purpose of these just so you don't have to be messing with it?
Yeah, it's so you don't have to do it when you're going full throttle cruise, full throttle cruise. As pilots, we mess with it for altitude, not for power setting. It's so that, and good question, maybe I didn't cover that well enough. The economizer or fuel enrichment is so that if I go from a medium power setting to a full power setting and back and forth, it'll automatically adjust essentially my mixture to be richer or leaner. The mixture setting in the cockpit is fine tuning, more related to what altitude I'm flying at to fine tune those changes. So there's a whole bunch of reasons as pilots that we might adjust it for power settings as well, but that has more to do with just that fine tuning. We'll get like really fine tuned in, and then we're like, okay, back to not fine tuned, I wanna go full power. All right, here's another picture of a, you'd call it second orifice. Now, the problem with this drawing that I don't like, and that's why I gave you the drawing, is the holes are so big. If I open this up, is it really gonna change fuel flow? Not really. So if they were to draw this over again, they should have drawn an orifice there and an orifice there, and that would have been more accurate for that particular card. But just throwing that out, so when you see the economizer one, that would be more accurate to draw if you were gonna be that kind. And what they're trying to show is in a full power setting, this would pull up and allow more fuel. And so I don't like that picture, but it shows up a lot of places, so I wanted to kind of point out what they're trying to show. They just did a poor job of it. That suction one we already covered, but I had had some pictures for you. Wow, look at that, can't see them at all like that. So, here's your idle discharge kind of stack ports, 1, 2, 3. My mixture for my idle is gonna be plugging that top one. Notice the hole just to the left of it there, and it shows up on this one as well. When I am with a partially closed throttle, that is basically above the bottom of my throttle plate. That is the hole that's going down to the float hole for a back suction economizer. So if you have one of these Marvel Shoveler carburetors, look real close. If you have one off to the left side, you absolutely have a back suction economizer on there. You go, oh, okay. If you don't have one off to the side, I'm not 100% sure. They drill a bunch of holes in weird places, but that's what that hole off to the left is. I highly recommend, I'm almost there, Leo. I highly recommend while you take these apart, I'll leave it off. If you can't figure out where the holes go, you can use like a real thin safety wire to try to kind of like push it through and see where it pops out at. I wouldn't do that on a real carb because we don't want to scrape them up when I say real carb, operating carb. The other thing is you can squirt a little WD-40 with a little red hose and see where in the world does it come out. That can also help you figure out where does that hole actually go. Is use a little WD-40. If you were to squirt it in here, you would go, oh, that just pops right out on the top of the bowl. Where these ones, if you squirt in, are going to end up draining down into where the jet screws up into the bottom of there. All right, Leo.
Go back like 2 pictures. One more. No. The main metering jet, how does it meter if it's, so if your economizer and your main inlet, in a sense, are both feeding that, what's it gonna change if your economizer opens up?
That's why I said I hate this picture.
Okay, so that
Yeah.
main metering jet should be before the economizer.
Yeah, theoretically, if they were gonna draw this, I drew it one way. The other way to do it would be to say, let's draw a passage here with another economizer metering jet.
Okay, no, makes
I don't think they were intending to show you how the economizer works when they drew this one. They messed up. So I'm not gonna have this one on the exam with asking you about the economizer, because that would be silly, because it's a bad drawing. I realize we're, kind of like John said, we're covering a lot of different style carburetors and components, and then when these pictures come up or they're in your book, or you see them, just to be like, if you're looking at it, you're like, I don't get how these things work. You're like, well, that's because some of them have drawings that aren't quite right. So, trying to point that out on this particular one. Good catch. All right. That's the one we just did. All right, then that brings us to the last one, which we've talked about a bit, kind of out of order. So it's my main air bleed shutoff economizer. I'm getting better with the name. I don't know, it'd be great if we had a name for that thing. Air bleed elimination economizer. And basically we're just gonna shut off our main air bleed when we're at the full throttle position. And I pointed that out a couple times. Take a good peek at that if you get a chance. You can actually trace through where the air is coming through in these little ports and stuff. I'm not gonna cover it much, but kind of like on your engines, how they have galleys, these little probably lead things are plugging off the end. So when they made this thing, they drilled out the passageway that needed to go from here over to somewhere, and then they hammer basically usually a piece of lead in there to seal it off. So you'll have those at various spots on carbs because you gotta get the passageway in there somewhere. It's hard to cast it in. I gave you the manual. If you were to go to the MA, I think it's 4-5 manual, you can read all about the thing and how the throttle lever has a valve up in there. Hard to see in a classroom setting though. On that one, even the manual gets a little tricky to see what's going on. They have one image that shows the air bleed. Notice the air bleed tube goes all the way up to where that valve is. So that's pretty much all the better they do at showing you that. They did not show us, well, how did the air get up to the valve in the first place? And the way the air got up to the valve in the first place was from behind here. There's a passageway that comes up to the valve. So even the manual, you gotta kind of know what's going on to know what's going on. So this little guy here has a screen behind it, and basically, if I'm gonna suck air in from behind the venturi, hopefully it's clean air, but maybe I had the carb heat set to hot. If I have the carb heat set to hot, I don't have an air filter anymore, do I? So I might have dust particles and stuff. So the air that comes in the bottom of my carb will actually go through this filter before it makes its way up to the valve up top and then back to our air bleed. So on these ones, when you see that sticking off the side, that's actually a screen or a filter so that if we get any dirt trying to go through our air bleed system, it says, nah, we're gonna stop dirt or particles before they get through. So carburetors will have screens and filters built into them in some other places. Let's see, what was this one? That was trying to essentially show it, but it didn't do a very good job. So we'll just keep moving on that one. Just some images. All right, so that one's not in your book, FYI. It just, they exist, they happen, and you need to kind of know about them. If you're looking in the bottom of that carb, there's the mechanism that goes up for both the accelerator pump, which we're gonna cover next, but also to work the valve up in the top. And they're kind of in your PowerPoint in case you wanna look at them. They're just some of the pictures of where the holes are going through. This one I got a screw sticking in the hole so you can see it that goes up to the air bleed for the economizer. So tried to take some pictures. You notice it's off to the side, so that's kind of the air bleed coming back down. That's the top, coming back down, which would then connect to here. These are gonna be clipped together, top side of the carb, bottom side of the carb, to get to our air bleed. So trace it through. It's a good little practice. 3 styles. Got it. We just got back from break, so let's keep rolling. What do you think? Yeah, keep rolling. All right. I had a boat, and every time we tried to get somebody out of the water in the boat, hit the gas, the boat would go. Anybody else had that problem in an engine before? All right, so the problem was my accelerator pump in my boat was not working. When we go from a partially open throttle to full throttle, the FAA likes to use the word abruptly. So if I go from partially open to full throttle abruptly, I'm going to almost instantaneously increase the amount of air going through, but it takes a second for that increased airflow. Now I got a lower pressure here, and it takes a second for the fuel to catch up with the air. So if you don't have a accelerator pump, what'll happen is when you abruptly go full throttle, you'll actually go lean for just a split second until everything can catch up. So you'll go, oh, there we go. Now we're running again. So you'll have an accelerator pump. So we're gonna cover that now or next. This is connected to the accelerator pump. And basically, when you go full throttle, there's a squirt gun that adds a little bit of extra fuel to get stuff going. Some of the accelerator pumps actually will act as an economizer as well. If you go full throttle, the accelerator pump will push on a little ball bearing that's at the bottom, opening a backflow or opening a valve, and it allows a little bit of extra fuel to be an economizer as well. Really rare, really weird, but this one tried to show that. It just didn't do a very good job of it. So some of those accelerator pumps have a dual feature of accelerator slash economizer, and I guess technically it'd be an enrichment valve then, wouldn't it? Same. All right. Funny. No, don't do that to me. All right, so on this one, here is our accelerator pump. So when I work the throttle, if I go open really fast, it's going to push that plunger down, and it's going to squirt a little bit of fuel into my system. There it goes. Go figure. Here's the card pulled apart. Nice blue. We'll cover floats tomorrow. That's kind of fun. What's this guy sticking up? Mixture control. So that one does not have a back suction. Mixtures at the valve. So over here hanging off to the side is the plunger for our economizer. Oop, said that wrong. Our accelerator. It's the plunger for our accelerator. That's going to go push a little bit in there. Here's a side view of a carburetor. Where is the mixture control on this one? I don't know if I come draw it or just give me directions. Trevor. Mixture, the main mixture control. What would I hook that red knob in the cabin to? That? Yeah, that's it. Yep. So that's the mixture control you're going to hook your mixture up to. Here's the throttle control. This little screw here is going to be our mixture adjustment that the mechanics adjust for idle, right? Our idle mixture adjustment. This little screw here, it's hard to see on that one, but basically as we move our throttle around, that stop's going to come down and hit on the screw. So that'll be our idle RPM adjustment screw on this particular car. Interesting picture we're going to cover later. You'll notice all these kind of washers with teeth bent up. Carburetors typically have that style for safety. It's really hard to do safety wire on a carburetor, so they make these fancy washers, and we'll hit that a little bit later, but it's a good slide to point it out on. You actually bend the ears of the washers to hold the bolts in place, so kind of clever. Let me make sure there's anything else on there. Okay, getting towards the end. So they're showing us what I call additional jet economizer. We might better call it an enrichment valve, right? So at full throttle, we would want this valve to open. So everybody with me on that so far? Full throttle, that valve opens. The difference is they don't have this hooked up to the actual throttle linkage anymore. What they did is they said, okay, here's the pivot point. So this whole thing's going to pivot on there. There's a spring with a set pressure. Inside here is an aneroid, basically. So it's got a set pressure in there. And then we go hook manifold pressure up to here. When do we have a high manifold pressure? Is a high manifold a high or a low power setting? High power setting, yep. So in a high power setting, high manifold pressure, we're going to try to compress that aneroid, which means this whole thing's going to tip down, opening our valve. So a high power setting, the actual high manifold pressure will open that second passageway to the orifice. If we want to call this an economizer instead of a power enrichment valve, we could start with it opened, and we could say, okay, I'm going to close my throttle a little bit. That's going to lower the manifold pressure, right? Lower manifold pressure is going to tend to say, oh, well, we'll let my aneroid expand now. Expanding aneroid is going to plug that off, leaning our mixture out in cruise, calling it a economizer. So kind of makes sense what's going on with that one? That's kind of cool. I like that. I think it's kind of expensive. So that I think is saved for larger carburetors typically. This is just a shot. I didn't know where to throw in, but here's one of the simple ones that has the back suction economizer, and I stuck some kind of screws in. This would be behind where the venturi sits. So picture, I have the venturi removed, that hole is behind it, so it's basically impact air. So it both goes in here, through that hole here would be going down to the air bleed. So from behind the venturi, we got a passageway down to the air bleed. And there's a screen there, I didn't want to point that out. That's a screen, so it's one more of those screens you're never going to clean. You can't get to that screen. But if I have carb heat hot, I don't want any little pieces of dirt that came through to come plug up my air bleeds. They install a little screen in there. So there's a passageway to the air bleed. There's also a passageway out to just the top of the float bowl, right? So it's got a passageway to the top of the float bowl. That's where the pressure normally is going to say transfer on top of the float bowl. And then you're going to have an additional hole to the top of the float bowl that's coming from up above or near the throttle plate. Yeah, you can leave the screen in, because if you take it out, you'll damage it. Probably, yeah. If it even has one, leave it in. Okay, if you want a refresher instead of watching me again, I gave you that link. The guy goes over what we've been teaching you, so you can open up the PowerPoint and watch it during lab or something. Maybe a different set of explanation, but I just gave you that. He does a pretty good job explaining it. All right, last concept before we do a real short review and head out to lab is our idle mixture adjustment. So we basically already covered this, but remember when we're at idle, we don't really have any, we have very low flow through our venturi, so we're not gonna have any fuel coming out because with low flow, low pressure drop, it's not enough to force fuel up. But the venturi effect by the edge of the throttle plate is drawing our fuel up through our idle jet. There's an air bleed. The very top hole in our carburetor typically has a needle valve that's coming in there. I drew that on day one, if you will. And we can adjust that needle valve to open or close that idle delivery port or idle jet. So that's this one on here. You'll all have some sort of mixture adjustment. And that's the one where you're going to start the airplane up. You're going to warm it up, get it nice and warm, and then you're going to come back to set RPM, and then you're going to lean the mixture control out, not that little screw, but the one in the cockpit. Hopefully you get an RPM rise, and then fall when the engine quits. If you were to do that, and you don't get an RPM rise and then fall, it's just a, hey, the engine just quit. Well, you were probably on the lean side. If you're on the lean side, not enough fuel, you would want to take that screw and back it out a little bit. Open up that orifice so that you're on the rich side, and then do it again. If you're really far on the rich side, the aircraft might not run very well out in the idle position. If you can make it run well by manually leaning it, you might say, oh, well, I must be way too rich. Or if your rise is like 200 RPM, you're like, oh, that was way too high RPM. I gotta lean this out. I gotta plug that hole off a little bit. So that's our idle mixture adjustment. That's not something the pilot does. That's something you, as the mechanic, would do. One whole slide for that. One of the only things you guys adjust. I'm going all day, you get one slide. But it's a simple concept. You just gotta practice it. Okay. And just quick review, the air bleed is to, they'll say decrease the fuel density. Yeah. It also bubbles it up. Mostly it destroys the surface tension of the fuel, but what you really need is it's better vaporization and control of the discharge, especially at low speeds. So just a review on why we do our main air bleed, both for the main nozzle and the idle nozzle. Okay, that's it. I'll take questions for 8 to 10 minutes, and then I'm going to take a 5-10 minute break, and then I'll catch up to you in the lab. I will have my notepad in case you need it on the list. Dismissed.
Have you opened the presentation today?
It's not open?
Like weird Google error.
Let me try again. I actually did it right before lunch. I'm gonna have to do it from my office. Let me try it from there. 1:30. That wouldn't be a bad way to go. What if I start taking reservations?
But then you're gonna have to rush with each person.
Yeah. Or I get a break if I get on early. That might not be good either.
On the schedule thing, it says don't reassemble carbon until you're done at lab 11.
I was just looking, it might be lab 11. Because the airblade accelerated pumps, economizers,
Carburetor floats.
yeah, maybe 11. If you notice the time on all the ones on the right, they're like a little less than an hour. So lab 11 is actually, if you want to look at it that way, not that far down your schedule. Most of these are just quick answer question labs.
Okay. I'm gonna go look at my carburetor. My carbohydrate.
And the other one is, you can either get ahead on these labs. Once we're done with tomorrow, I think you've been taught what you need to go all the way through 11.
It says, yeah, it says it's labs 3 and 4 and 5.
Well, and that's, when I do that schedule, part of it's just to give you an idea of, it's more am I on pace?
I find that
Am I
helps
ahead?
with the little calendar blocks you got.
Yeah, but the idea would be, where's my other one? Once I'm done lecturing, I think tomorrow, where's my lecture schedule? You'll have basically your carb info to do all the way through 11.
After tomorrow, you said?
I believe it's after tomorrow. I don't see that one schedule. So if you wanted to jump ahead, there are a couple different ways, or you could get going on start the engine, pull the carb off an engine, or just keep working towards 11. Get ahead of it. There it is. Nope, that's 2024. Yeah, that's pretty much it. Yeah. Basically after tomorrow.